This is one. The problem, I can tell you what is the problem. Uh, yeah, tuple I missed. I have to discuss about tuple. Yeah, say my problem is that, say I have a data file, and in the data file there are some files, there are some things written on this: 1 2.1 2 3.7 3 8.9 4 5.2 4 2.1. These things are written, and I want to read this file. I want to write this 1 2 3, the left column, 1 2 3 4 5 in a separate list. I want to write 2.1 3.7 8.9 5.2 2.2 2.1 is in another list. So I want to create two lists, A and B. One list will contain the left hand column, this another list will contain the right hand column. How to do this? Using, now let's see the program. Now I've already in my computer has some data written. Its name is sumdata.txt. It's there in my directory. So the thing is, first of all, you have to open this file and give it a name of this file. I mean, the file handler. You have to give a name to it. So you first, this is the keyword is open. Open is your keyword, and then within the code you mention the name of the file that you want to read. And if it is not there in your this directory, then you provide the path of it where it is present. And then another thing, the mode in which you want to create the file. For example, I want to create the I want to use the file for reading, so I write R here. If I could have written W if I wanted to write, and could have written A if I wanted to do append on the file. So the reading mode, I'm creating opening a file called sumdata.txt, and then the file is not yet open. I mean, it will. Then I want to create two lists. I said that the name of the list will be A and B. In the program itself, I wrote X and Y. X and Y are two blank lists that I created before doing anything. Now I run a loop on F. If I run a loop on F, where F is a file handler, what it will do, it will go on the list and read the list sequentially. If the list is something like this, then the first row of the first line of the file, it will read as a string. The entire first line, it will read as a string. So 1 blank 2.1 would be a string. Then 2 blank 3.7 will be the string in the next go. 3 blank 8.9 will be the string in the next go. So I know, so what will be the value of my I? I will be a string which contains two numbers separated by a blank. And of course, in the end of the file, there will be a end line, a new line character, which I wanted to ignore. So I just said if I is not new line, is not new line, but so ignore the last line. Then what you do, you first come here and you do this string which contains two number given by two as a string separated by a blank space. You split that. So if you split that, then this numbers, this one is 1 2.1 kind of a thing, which were two numbers separated by strings, will be now 1 quotation and 2.1 quotation. So two strings, the first number, comma, first number as a string, second number as a string, and a list of two strings will be there in the SL. So SL will be the list which contains two strings. Now, the first one of this list is the first element of the column. So that is SL0. I evaluated that. When I did evaluated, then string will be converted to number. Now I append that to X. And what is that one element? Is the second element of the list. That will be converted to another number and then added to the list Y. Okay. So then I wanted to print them. I see what it is. Run this. So X is this, Y is this. These were my list, and these are safely read. So that is how you read a file using the eval method. And once I have already talked about how to write a file, I read a file, I should also mention how to write a file, for example. That completes my discussion. For example, I created a list. For xi is a range 1 to 10. So it starts from 1, ends at 10. And then uh, let me see that my directory doesn't contain any file called mw.d. That will be, otherwise that will be a cheating kind of a thing. Because is a directory. Uh, doesn't let me see. Yeah, it contains it. So just delete this. So the point is, so I created a list of numbers from 1 to 9, and then I used a list comprehension. So I divided each number by multiplied each number by point 1. So now my x will contain 0.1 to 0.9, and then I use another list comprehension to get the x square from the x. So 0.1 square, 0.2 square, etc. So I wanted to write them in a list. So the way is to that you again open a file. This time the name of the file is mw.d, and then you open it in the write mode. So this is, and then you run a loop, print xi yi, xi comma yi, and in the file f. That is the trick. If you want to, if you don't give file f, it writes to the screen, and if you give file f, it writes to the file. Okay, you run this. You run this. Apparently, no problem. So you go to the directory to see if it is there. Okay, it is there. The MW file is created. You can see. I don't know whether you can see this. These are 0.1, 0.2 up to 0.9 and the squares. So that is how you can read a file, you can write a file. Of course, when we will learn NumPy, we will see that there are much better methods of handling files. These are much easier. We don't have to do so many tricks. These are just much simpler, but I'll just show you that using these two things, you can do this also. Okay. And now I should also talk about something called tuple. String I have talked about. I have to talk about something called tuple. Now, what is tuple? Tuple is some very much like a list, but there are two important differences. One is that if I want to create a tuple, instead of third bracket, I use a first bracket. So sorry. If I start with first bracket, I have to end with first bracket also. So this is it. So this is my, what is this? Let's see. I used first bracket, it didn't object. So what it is? It is a tuple. So tuple is a collection of object once again. So it is very much like list. But one difference I can see is that it starts with, so instead of third bracket, it has first brackets. And what if I forget to give the brackets also? Like just few numbers separated by commas. And what is A? What is A? Type A. Type A. A is again tuple. It simply says that I can give this first brackets. Even it doesn't matter if I forget to give the first brackets also, even that then it is a tuple. So a few numbers separated by commas is a tuple. But you can refer to the elements of the tuple the way you refer to the elements of the list. The similar way you can do that. But remember that tuple is an immutable one, like the list. You once created, you cannot change the elements of the tuple. It's immutable, like list. And for example, so I have, say, a tuple of, say, two numbers, 2, 3. This is it. So what it does, I gave two numbers, 2 and 3. I didn't give the first bracket. It packs them to a single entity. So it's called packing. This is a facility of the tuple, which is called packing. These two numbers given by separated by commas didn't mention any bracket or anything. So they will be packed to a tuple. So this is called packing. Once again, if these two numbers, say A has two components, right? So I can unpack them also. For example, I can say A, B equal to A. So what happened? A has already two components. The first component will go to A, and the second, let's say, A is to
Urnapada, can you repeat the file writing thing? Some participant is asking. File writing procedure. You can explain more.
File writing is already there.
No, can you explain that again? Some confusion about this thing.
Okay, let's confuse you. I created two lists. One list, first a range, numbers 1 to 9, and then I created a list which is, say, I divided each number by 10. So 0.1 to 0.9 remains in X, and I squared them up. Each number I squared them to get a Y. So I have X, I have a Y. I want to write them in a list. So in the first column, there will be 0.1, 0.2, 0.3, and then the second column, there will be 0.1 square, 0.2 square, etc. in a list. So all I have to do, I ran a list loop. Say, for example, look at this loop. Forget about this portion. The portion I highlighted in blue. Forget about this. If you didn't have this one, then what it would do, it will just print the xi and the yi. So 0.1, 0.1 square. In the next go, it will print to 0.2, 0.2 square. In the next go, it will print to 0.3, 0.3 square, right? But the extra thing I did is the mention of a file equal to f. That tells it that instead of writing on the screen, you write it in the f. And what is f? F is defined over here. This is f. That's it. So you already defined what is your writing device, if, and then just mention this is what is your writing device, file equal to f. If you don't mention that, it will be written on your screen. If you mention that, it will be written on your on the file itself. That's it. I think it's clear, right? So now we are talking about the unpacking. So here I showed you an example of packing. I gave two numbers without mentioning any bracket or anything. These two numbers are now packed into a single quantity A, which is like this. So it's called tuple packing. And now here A comma B equal to A. Apparently A is a single number, but A is actually a tuple. It has two components. I can unpack them by A comma B, etc. Okay. So of course, the number of components that you mention here in the left-hand side should be equal to the number of components that the tuple has. If the tuple has 3 components and you mention 4 components on the left-hand side, this will not work. It has to match. Now, this actually gives you the famous Python swap A comma B equal to, A comma B equal to B comma A. When I write it, what happens? This B comma A is packed into a single quantity from the right hand side, and then it's unpacked into the left hand side. Okay, so it's packed from the right hand side first, and then it is unpacked in the left hand side. So A, B, and A goes there, and then in a single packet, and from that packet now the first element is assigned to A. So now the value of B is now assigned to A, and the value of A will be assigned to B. That is what it does. Simultaneous packing and unpacking gives you the famous Pythonish swap A comma B equal to B comma A. Now the important thing is that I just wanted to show you something here. That look at this. So A is a list of list, kind of a matrix. 532, 331, 731 is a list of list. Now, if I say for I in A, it will be it will show me each list. Now, if I do A0 comma A2 equal to A2 comma A0, the entire rows will be shifted, right? The entire rows will be swapped. They are now single entities. That A0 is a single entity, A2 is a single entity. A2 and A0 will be a tuple of two lists, packed and then in the unpacked in the left hand side. So what you get here, the two rows are shifted. Now you can see A0 and 2, 0 is here and 2 is here. The first and the third list, 532, 371. You see, they're swapped in a single go. Because you can apply this, I mean, the flexibility that you can have tuples of numbers, you can have tuples of strings, you can have tuples of lists also. See here what happens, you create a tuple of list and you unpack that. So you can do it in a very intelligent way to swap the rows altogether. Now I would like to mention some programs, some interesting programs, for example.
Urnaboda, can we give a 10 minutes break?
Yeah, I don't mind. I thought that I was talking at 5. Okay, if you like, we can also have a 10 minutes break. Right.
Okay, so we will return within 10 minutes.
China to কিছু নাই
In the meantime, if there is any question, I'll be happy to answer. I mean, if there is a question,
yes,
any question.
Sure.
As I'm not speaking, anybody who would like to put a question can unmute his or her speaker microphone and talk to me directly.
Sir, I have a question.
Yes, please.
Yeah. So while reading a suppose a text file, so when we are applying the for loop, every time it is reading string. So my question is, in the det file, does it matter how the two columns are arranged? I mean, in between it has to be space or it has to be tab. That's what I want to know.
Yeah, because the split, it depends on the split. If you know that they are separated with tab, then you could, this, I can show you this just here. Take, right, okay. For example, help.
Nabuda, just to interrupt, if you were actually using tabs or spaces, default split will work because split only takes white spaces by default. Any white space, tab is also white space. So,
right.
As far as split is concerned, tab or a space doesn't matter. If it's comma, then of course you're separately.
Right. Yeah, that's it. Oh, sorry. I just wanted to show you this.
Yeah.
Split. I have to go to split. See, it is separator. You can see you mentioned split, list your string dot split, but then if you have your separator as comma, for example, then you mention that sep equal to comma within quote, of course, because normally you don't have to mention a separator, but if you have a separator, for example, comma, then you mention sep equal to within quote comma. That will work.
Okay, thank you.
Sir, I have a question.
Yeah,
Sir,
please.
the last topic, the swapping, does it limited by row swapping? In case of column swapping,
No,
does it
because in this case, the way we treated each row is a single entity, but the columns do not have any entity, so we cannot change that way.
So basically, the point is this is not really a matrix. This looks like a matrix.
Yeah,
You can make it
yeah.
work like that, but this is just a list of lists.
Yeah.
Well, with NumPy, things are a bit better, or not a bit, a lot better.
Lot better.
NumPy actually uses things which are very much more like matrices, but it actually has a matrix class on its own. There, all these things that you're talking about could be done, but this is just sort of trying to make something look like a matrix when it's really not. Can we open both text and data file in Python? What do you mean exactly by that? I'm not very sure. Shama had a question.
I didn't see the question.
Yeah, it was typed.
Sorry.
No, data file means what? If the data file is in standard text, .dat file might look. But the problem with this idea, the .dat file may be a plain text file, may be a different kind of encrypted file, specially encrypted file for some application. If it's a plain text file, you can open it just like any text file.
Right.
For specialized application, then it's a different thing altogether. Then it will depend on whether that specialized file application is known to Python. There are several examples. You might have a very unusual .dat file. Those .dat files are usually just numbers. You can always open them. That's just text.
Okay, I have one more question.
Go ahead.
Yeah. So, suppose the dat file, besides the numbers, it also contains strings, maybe some characters. But I want to isolate only the numbers. So, can we remove the strings from the dat file?
Of course, you can. After all, when you're reading a file, you can read the file entirely as a single string. After which, how you process that depends on what kind of string processing you can do. And you can do almost anything you want.
Yeah.
The only point is, maybe
this absolutely answer. The I is when you read a particular line, I is the entire line in the string format. And then when I use SL to split that into individual words, I mean separate by the white spaces, you separate them. Now, if one of the string is for example, your non-wanted character, you don't process that. You remove that. I mean, you process the ones you need. For example, I process the 0th component and the first component. If you know your unusable component is the third component, you just don't process that.
And you can also do much more complicated things. The real point is string file manipulation in basic Python looks a bit complicated for the simple reason that it is very, very powerful. You can do almost anything you want with it. As a result, of course, even simple things are not doable just in one line. Whereas, say, Onawada was mentioning NumPy allows you to do it much more easily, but that's because NumPy assumes that your file is much more limited. As only certain kinds of things and not other things. Only numbers, for example. However, Python actually assumes that your file could be anything, including unreadable characters and so on. and gives you ways of handling all of them by using string manipulation. More powerful, hence more complicated. That's it.
I have one question.
Please
Hello?
carry on.
Suppose you have a list A1 and which has elements say 1, 2, 3. And as you have mentioned, suppose
I will give the context of the question. In which context you are asking the question?
list.
List. Okay. You are talking about a list. Okay.
Yeah. Suppose you have a list called A1 and say there are elements say 1, 2, 3, 1, 2, 3 in the list.
Why don't we write it up? A1 equal to
1, 2, 3. It's a list.
1, 2, 3.
Yeah, exactly.
That's it. Okay.
Now I keep B1 is A1.
B1 is
A1.
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 You
A1
mean
is
A's first element or A1?
A1 is a list, huh?
A1. A1.
And that's it.
Remove the bracket.
No third bracket, I guess.
B1.
No, I guess he means B1 is A1. It is just same list.
B1 is
Copy
A1.
of A1.
Okay. This is B1 is A1.
Exactly. Yeah, that is. Yes.
Should I put
Now,
enter?
if I change, yes, you put enter.
No, then B1
now
and
if I
A1
change,
are the two
say,
alternative names of the same list.
So that is the point that Munawwar made earlier. This is not a copy. This is the same list, same memory location, exactly same place.
There are two alternative names of the same list.
Yes, that's what. Yes, that's what I'm saying. If I now change A1, any element of A1, say A1 0 to say 5.
The corresponding changes will be reflected in B1 also.
But I mean, if A1 is a single variable, suppose A1 is not a list, A1 is a single number, then that will not be the case.
That will not be the case, yeah. Yeah, definitely.
I mean, what is the difference?
So that is a very lengthy question to answer. So short answer is this kind of thing only happens for lists. The long answer is lists. For variables, things work the same way that you expect them to work. A equal to B is an assignment. When you change, after you change B, A doesn't change. Frankly, it's really more complicated than that internally. But that's the one thing that has to be remembered. I think we can discuss this, but it will take a long time to discuss. But short rule is lists behave differently simply because they take up a lot of space. Copying them to a different memory location every time you reassign may be expensive. And because you have only written a 3-element list, it could be a million element list. Right?
Yes.
And if you really wanted suppose you wrote B1 equal to A1. If that were if you wanted a copy, then you will have to officially copy it.
Okay. I mean, do they store them in the same location? Sorry. Audio is lost again.
B1 equal to A1, the location is not changed. The name is, you just assign two different names to the same list.
Yes. And when I change an particular element of A1, then the memory location remains the same?
Anandu, does it remain the same? I'm not very sure about the internal working of the Python.
But what I have seen that for a single variable, the memory location actually changed. And if A is a single variable, if you put ID will show you the memory location. Then for a single variable, it is different, always different.
Let's see. A0, ID of A0.
ID of A, enter A.
ID of enter A.
A1.
ID of A1, that's round bracket. ID is the function. ID round bracket A1.
Right. ID is a function.
Yeah.
Sorry.
ID A1, ID B1 are the same.
Yeah. ID of A1.
No, A1, the name A1. Round bracket A1.
A1.
capital A.
This is the location. Yes, yes, yes.
ID
And
of
that same is
An ID of B1 will be
B1.
exactly
B1.
Yes, they are the same. Now, if I change an element of A1, will the memory location be the same? I mean,
no. That there is a bit of a confusion about this. The memory location of an element of A1 is not the
the
same as the
entire
location
A1.
of A1.
No,
A1's location will not
entire
change.
A1.
A1's
But the
location will
location
not
of A1 will not change.
the memory location of A1's element will change.
But entire A1 will not change.
Yeah, and so as a result, B1 will also point to the same place.
And for a single variable, it is a different thing, right?
So for single variable, okay, this is what I wanted to avoid because that clashes with the kind of picture which people
Oh,
have
okay.
for the way memory locations are
Oh,
handled.
okay, okay.
Frankly, the myths that we have about the way memory locations are handled, which people are sometimes taught, is
Okay.
wrong. Is wrong for all programming languages. Python just makes it
Okay.
explicit. So the idea that memory elements are just stored in boxes and that's the way computers handle it, that used to happen 40 years ago. Modern systems work differently. And
Oh, okay.
the problem is that is what Python fully exploits the modern system, which is why it sometimes looks a bit strange. You have learned the old thing. Like everybody learns, frankly.
Hello.
Okay.
And this is a bit too advanced, so maybe we can talk about this
Okay,
later.
okay. Okay.
Hello.
Yeah,
Thank
yeah.
you. Thank you.
Yeah.
Please.
Is there any option to read and write simultaneously in Python as in C or other language? In
Yeah.
file writing?
There is, it's dangerous to do, but you can do that. RW.
Hello.
You have
Yes.
RW.
Answer is given.
RW.
If you
Okay, that
your
is the
mode is
same as
RW, you can read
C.
and write.
Okay.
Yeah, but it's not a very advisable idea. Sometimes it might screw up what you're trying to do, unless you're very careful.
I think 10 minutes are gone and I can continue
Yeah,
with
I
my
think we should
Yes,
conclude.
yes, yes,
Okay.
yes.
Now I have to talk about two different things. Two more things I think. One is dictionary, one is set. Now dictionary is a collection of elements which are paired. Like let me go to the presentation. That's it. Yeah, like this. In creating a dictionary also, you keep two second brackets and then you pair them up. Like here, I pair this string is paired with 35, Keka is paired with 44, and Sagota is paired with 30. These pairs are dictionaries are paired entries, and the first of this pair is called keys, and the second of the pair is called values. So you get A dot keys, you get all the keys that you have entered. You get K dot values, so you get all the values. And if you want to refer to, for example, the value of say one of the keys, for example, what is the value of A whose key is Keka, you get the value 44. If you want to say what is the, if you want to change this, if for example A of Sumi, which was 34, 35, you want to change to 39, you can do that. The see Sumi is now 39. That's it. Dictionary, you can always have paired entries. That's what I wanted to tell about this. And then I will talk about something very interesting called set. Set A is equal to, for example, what is this? It's a set. And if I see what it is, see what I entered here and what I get here are different. What I entered here is 2, 3, 4, 2, 3, 2. There were 2 3s and 2 2s, but you see, you only get the distinct elements. So you get a this thing, and the set will remember only the distinct elements. Okay, and then this is a set, and you can define another set. For example, this is another set, type of B is a set, and then you can do the set theoretic operations like A dot union of B. So you see the set, look at set A and set B. Oh, these were the same set. Okay, let's have a different set. B equal to now A dot union B. You can see this actual the union of two sets, and you can also have a intersection like this. Intersection of B. Just the set theoretic operations you can do, and so it's a useful if you want to, from a list, for example, you want to get the non-repeating, the distinct values, you can find out them by using what do you call it, set. Let me show you an example of this mode calculation. Say this is a list. X is a list of numbers, if you can see. X is a long list of number having some repetition. I want to calculate the mode, the highest frequency, the one which has the highest frequency. I want to calculate that. So if we want to do it in other languages, the first problem that occurs is to find out the numbers which are distinct. So which is easier for here. I just first create x distinct, which are set of x, but I want to convert it to list once again. So xd now converts the distinct numbers from this list. Okay. Then what I do, I count, take every element from xd, which are distinct elements of x, and then count the occurrence of each of these numbers. From xd, I take every element. I find out the count of this, how many times this element is repeated in x. So this becomes my frequencies. So I want to have a good display of that. So I use a facility called zip. If I give two lists and use a facility called zip, then what will happen? This will give you a kind of thing, a paired output. So it will generate a list taking the first element of xd and first element of f, making a tuple, and the second element of xd and the second element of f, making a tuple, third element of xd and the third element of f, making a tuple, and that will be a new list. So that I call f table. Let's just run this up to this much. Then so this is my data, and the frequency table is this. It tells me that there are distinct values like 13, 10, 5, 14. 13 comes 6 times, 10 comes 9 times, 5 comes 17 times, and 14 comes 8 times. That is very easy to find out by using two commands. One is set, another is count. Now I have to find out what is the maximum count. That is very easy. From the f, which contains the frequencies, I just simply have to find out which is maximum, max of f. That gives me the highest frequency. Now I want to know for which value this highest frequency occurred. So I wanted to know the position of this max f in the list f. So I just give f dot index of mxf. Mxf is the highest frequency that I got, and what is the position in the F table? That is the IX. So I wanted to know IX is the position, and XD is the original values, and the XD is the position, and the F is the corresponding frequencies. So I know which position the highest frequency offered. So I wanted to know at which position of X, is the corresponding position of XD, what is there. So that is it. The mode is that number which corresponds to the highest frequency. So run that. So you see, we already know that 17 is the highest frequency corresponding to the value 5. So gives me 5. So only a few line experiments, a few line code gives me the mode. And I will show you some more interesting programs. For example, okay, this one. Just I almost have completed what are there to discuss, but I wanted to show you some programs. For example, here I wanted to write a program which is something like that. I have a string and I want to shift the strings by a definite amount of steps. Like for example, if I give step 2, then I will change every character by 2. For example, A I will change by C, B I'll change by D, C will change by two characters. Just alphabetically progress by 2 characters and generate a new string. That will be a kind of a coded string. Okay, so I'll read out the string and just each character I'll change by adding going up. So I input A is to be eval. No, this is not eval. This is the original string. There is no point eval. So A is the original string I'm reading. Step is the step by which I want to change. I read, and then B is the string that I'm going to create by encoded string, and then S is the ORD is the corresponding ASCII number. So if I give a character and give ORD, that will give me the ASCII number. Okay. So just started with some value of X, and then for L in A, what is A? A is a string. So I read each character of the string, and then if it is an alphabetical character, then if is alpha, this is a Boolean of function. If it is an alphabetical character, then the whole thing will be true. Then this will be executed. Otherwise, if it is not an alphabetical character, then this won't be executed. I'll just get the L itself. The P will be, if there is a non-alphabetical character, the non-alphabetical character will simply be concatenated in P. So all the non-alphabetical characters will be simply concatenated in B, but the alphabetical characters, the ASCII value will be calculated, and the ASCII value of A will be deduced from that. So I know from A how much distant this particular character is. With on top of that, I will just add step. So I'm shifting the ASCII value by some amount, and I'll take the percentage bit to 6. So I don't allow it to go beyond Z. If it goes beyond Z, this percentage will ensure that I'll get back to 0, and then add the ASCII character of S. So ASCII character of A. So the whole thing will be shifted by a number, but if it goes beyond Z, it will start from A, I mean from the other side. So and if I do that, then the whole thing that I get, I convert it back to CHR. CHR is a number. Odd is the ASCII value. CHR is the corresponding character. So I generate a ASCII value by this transformation. I take the character of that and I concatenate with P. So let's run that. Oh, sorry. I gave an extra bracket to that.
Arunahuda, can you show the mode thing again? There's
I'll do that.
Some questions. Okay.
I'll do that later on. Just let me finish this. So enter a string. So it is my string and shifted by say 2 characters. No, sorry. I assume that everything will be in lowercase. Okay. Now aim is shifted by 2, y is shifted by 2, y is shifted by 2, y, z, and it gives a. So it enters it from the other side. So I get a code like thing. And okay, so I copy this and run the program once again. Enter a string by -2. I get it back. So this is one of the application of the string concatenation, etc. So somebody wanted to know the mode calculation. Yeah, yes, here it is. What's the question? Please pick up. I would know.
Firstly, people wanted to see the explanation once again, I guess.
Oh,
And there was a question that is, if there are two numbers which are the same frequency, say the maximal frequency is repeated,
max
then
finds
does
out
your
the first one.
yeah then your program does not really handle
Yeah,
that
right,
case
right.
separately,
Yeah,
right?
definitely. No, it's very simple program. It has if there are two peaks of the same height, it will distinguish between that. It finds out the first one because the index will find out the first one.
Yeah, you can actually
And
change that. You can
yeah,
recode that differently. But
yeah,
anyway, in
it
this
can
particular
be
code, then
recoded
it doesn't take
because
that into
index finds the first occurrence of MXF. So it will find out the first occurrence of the the, if the value with at where MXF occurs first. The explanation once again. This is the list I had, and then I operated set on that. So I got the distinct values of x, and then I converted to a list. So now xd contains the difference between x and xd is x contains repeated values, where xd contains only the distinct values. Okay. Then I created another list using list comprehension, where each element of this new list f contains the counts of counts of what xd contains the distinct values. I take each of the distinct values, I get the count of these distinct values in the original list. So for example, when it takes 5, it calculates how many times 5 appears in the whole list and it puts there. So it goes for all distinct values, and we have the counts here as f, right? And then this one is a for you I mean, good display. Zip is I mean I could easily I mean omit this one. This is just for the display, that if I wanted to know which value occurred how many times side by side, so I operated zip on that. Zip is a facility where you place two lists and it creates a list. Because of this list, it creates a list which consists of tuples. Tuples will be consist of the first element of xd, first element of f, second element of fd, second element of f, third element of xd, third element of f, this way. So the first element of f is one of the element that is appearing in f, and f is the xd, and what is f? The corresponding count. So what I get here is the how 5 and how many times 5 is repeated. 13, how many times 13 is repeated is something f table that I can see in my display. Run it once again. So this is the frequency table. How many times it appeared. And then what I have to do, in a very simple program, it calculates the maximum of this f. Maximum of this f is this mxf. So I know what is the highest frequency. Then I wanted to know where exactly this highest frequency occurred in this f, in this table f. So what is this? This is the index. I use the concept index of mxf. At which position this mxf occurred? I keep that as ix, and then I wanted to know in the original xd list what is the corresponding value. That gave rise to maximum frequency. So all I have to do is to call xd of ix. That will tell me that that value of ix xd gives me the highest frequency. That's what I do.
Yeah. So, of course, the question that was asked was if you had several different entries with the same peak value,
the first one will be
you will get, in this code, you will get the first one.
First one, because that is not a, I mean, it's a very simple code. It assumes that no such thing will occur.
Yeah, and if you can actually enumerate out all the occurrence of a particular number,
Right.
and then you can use the average of all those. You can just rewrite the code. It's not as if this is the only thing you can do, but that will make the code a bit more complicated. Well, not very complicated, just one more line.
To develop a good code for mode here, my aim was to just show a use of some methods, and as well as the use of the use of set. Okay, now I will show you some interesting things like this one. This one is word and line count. For example, I have a file, sumfile.txt. Let's see what it is. It can be found out. Okay, sumfile.txt. Oof. Yeah, sumfile. Sumfile is here. So this is the file which has several lines. So what I wanted to do here is line count and word count. That's it. So what I did here, I first opened the file with F and then set WC equal to 0, NL equal to 0. And then I went ran a loop for each line of the loop. And if it is not a new line, the last one will be a new line. I ignored that. Then yeah, because every sentence, in the end of each string, there was a new line which I wanted to remove. So I removed the new lines at the end of each line, and then I just counted the lines. NL equal to NL plus 1, NL equal to 0. So number of term lines I counted, and then word count. Word count is J is the new string that I created by replacing the new line. So I split the J. It is split into the words, and I counted how many words are there, and just added to WC. Right. So that gives me number of lines and number of words. That is the program, and this is my sum file. It definitely contains 3 lines and some words. So just run this. No, not this one. WCWL, yeah. Number of lines is this, number of words is this. It's just to see show you the usage of these methods. Another thing I forget to mention, okay, this is an interesting, I mean, not that interesting. This is a list over here. This is a list over here. A is a list, which I wanted to find out the local maxima. I wanted to find out the local maxima. The local maxima means, you say 76 is a local maxima because it is greater than 32 and 68. And so is 104 because it is greater than 101 and 100. Just wanted to catch this two. So, okay. So, so what I did, the idea is very simple. You do a list comprehension. You take those AIs for I in the range this. I just went one step less and didn't start with the 1 because I will compare with the previous one and the next one. So I have to start with this and start with not 0. I have to start with 1 and cannot end at the end. I have to stop here. So that is why I started with 1 and ended with lane minus 1. Okay. And my condition is that if AI is greater than AI minus 1 and also greater than AI plus 1, just pick that out. So just print I, that will give me local maxima. And if I want the positions of those local maxima, it's just simple. Instead of AI, what I have to place here is I. But I don't, instead of index, I just wanted to do the positions. The difference between index and position is the first position is called 0 index, but first position. So I want to refer the positions. So here, instead of I wrote I plus 1. So I just wanted to write the positions, those positions where this condition is true. So run the program. So I know already that 76 and 104 is the local maxima. So I run this program. See, this is the right local maxima is 76 and 104 appears at 2 and appears at 9. So that's it. This is a local maxima, appears at 2, and 2 is because it's 2 position, not 2 index, because I added a +1 here. It's a simple English language. At the second position and the 9th position it appears. It's not index. And another application is this one. But before going that, I want to show you something interesting about. I didn't talk about this. This is sort. The least. The least and the strings have a least particularly has a method called sort. If I have a list, for example, this is a list, and if I just write a dot sort, nothing gives me. So that means there is no return. A itself is changed. A itself is changed and is sorted. Sorting a list is that simple. So it's that. And I want to show you, just refer to you something. Just open sort compare. Yeah, sort compare is here. So this is a program which is a lengthy program. I just wanted to tell you that what does this program do? This program generates of 5,000 random numbers. OBC has talked about a random module. So I imported that random module here also, and then I also wanted to time the program. So I can, from the time module, I imported time. So I wanted to generate 5,000 numbers, which are random numbers from 0 to 1. I kept that in a file A. And then I wanted to copy them, several copies of that. So A, B, B1, C, D. There are all copies of A. So if I apply this copy method, then even if I change A, B will not be changed. So it is not A equal to B. I said A equal to A dot copy B. So this is also a safe copy of B. If A is changed, B will not be changed. So unsorted things are kept in A, B, B1, C, and D. And then I wrote a bubble sort the way usually it is written in any other language. The only thing I took that I use a Python kind of swapping. Then I use a selection sort. Selection sort can be written 2 ways. Selection sort, you know that you have to find out the maximum and it swap to the end. I mean, so this is how I this finding out the maximum and its position can be done 2 ways. One, using the max utility of function of Python and the index function of the Python. I did that way, and this one is a C-ish way without using this max and index, etc. I just use the simple C-ish way of loop, and then I did an insertion sort where I use pop and insert. I've talked about pop and insert, so I use this one, and then finally I use this d dot sort of the Python sort as a method of Python, which is called tim sort. So I ran this program, and see, I'm calling the time for several times. Just before starting this bubble sort, I measured the time T1. Just before, after completion of this bubble sort, when it goes to selection sort, I measured the T2 once again, and then so several times I measured the times, and I now wanted to print the time differences so that I know how many times it took, how much time it took for doing the bubble sort, for selection sort, using Pythonish way. Pythonish way means counting the max and the position, and the loop and the tim sort. So shall I run it? I mean, it may take a few minutes because 5,000 takes a few minutes.
5,000 shouldn't take a few minutes. Oh, you are using bubble sort and other slower sorts as well.
Yeah, it's done. So it says the bubble sort took 4.41 seconds. Selection sort Pythonish way took 0.4 seconds. Selection sort using loop without using the max and the index took 1.171 seconds. Insertion sort took 2.19 seconds. Whereas the tim sort, the sort given by the Python sort, took 0.0099 seconds. So that tells us the efficiency of the sort, so how fast it is, and it also talks about something. You look at the selection sort at two different ways. I just use two Python methods, max and index, and here I didn't use that, but that actually give me a huge time difference. So the take-home message we wanted to convey that if I have to write things in Python, it is not advisable that I implement it in a C-ish way. I should use all the methods and the functions, those are available in Python. So I have to be Pythonish way. It's something like Python is easy in one sense that its implementation of the things are easier, but it's like a well-developed language that has more words. If I have to express myself efficiently, I have to be aware of the words that aware of the functions that are there. There are a huge number of functions, and then I have to use them. One of my students says that if you give me an assignment, I won't write it. Just sit to write the program. I'll spend several hours to see whether some functions are there to implement this thing in Python itself, or there are some bits and pieces which I can stitch and do the Python implementation immediately. It is worth. I mean, you give some time before you start writing your program. Try to see whether the things are already there, or the bits and pieces are there which you can use. Now, the last thing that I wanted
to interrupt. This happens to be a very standard thing in the Python world. The standard rule is you never write a program. Right. So somebody already has much better programs written for you. All you have to know is where to look. It usually takes a few minutes, not several hours.
No, if you want
to know how to use Google properly.
If you have to do Google, I mean, just do it. I mean, don't write it. There are several things written down. You have to search for that and you stitch. You perhaps get it done. Now I'll show you one more thing. That is a sort, but for a list of strings, right? So see what I did. First, I have several names, and I did simple-minded a dot sort. Let's run it. Original list is Obhijit, Ananda, this. The A dot sort gives me an alphabetical list. Obhijit, Ananda, Arunabh, Kishore, Shubham. You can see that alphabetically Obhijit comes before Ananda, and then Arunabh, and then Kishore and Shubham. Right. Then I did I said reversed equal to true. So it will do the alphabetical sort, but in a reversed way. So see, then it starts from Shuman, ends with Obhijit. That's always there. You can always do a reverse search. But in the sort, you just give reverse equal to true. The next is a dot sort key equal to len. Len means you don't do it alphabetical search. Rather, you do it on the length of the string. The length of the string, when I gave it, then Shuman, Obhijit, say this is highest. This has this one, I think. Yeah. Yeah. Alphabetical. Yeah. Because Shumon and Abhijit has same length, so they will come here, and the higher number of names. So it's a small to higher kind of a. So I can change I can put some keywords to denote which should be the criteria of my string search. For example, this is a array of strings, but actually they are numbers. Actually, they are numbers, right? So my key is int. So convert them into integer and then do the sorting. So if I do that, you can see. Because it has a larger length, I think it comes here, right? Oh, yeah. Among these 12 and 012, 0 has a larger length, so it comes later, and then 42 and 123. So it converts them into the value numbers and then does the search. So sort has different keywords also that fixes the criteria by which you can do this.
Onawuda, the 12 and 012 are in that order simply because they were in that order in the original list.
Original list,
the length has nothing to do with it.
Right.
The integers are the same. So 12 and 012 are both 12.
Right. That is why I think, yeah, right. Okay. So that's it. I think I can stop here. The things that I was supposed to say is complete. Now, if there is any question, I'll be happy to answer. And Anand is also there to answer.
Excuse me. Hello.
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 Go ahead.
Yeah. Can please show the code of that alphabet one where you typed your name and the letter characters, like the letters changed.
I think he was talking about the Caesar
string
shift
coding. String coding, right?
Yes. Thank you. Can you just explain once again, because
yeah, my idea, the idea was that the ABCD, these things, the ASCII codes for A to Z are consecutively placed, but it doesn't start from 0. So they are consecutively placed. So I have to do a shift kind of thing. Any given character, I just want to give a shift of, say, constant shift of some characters. But then what happens that it can, if a number is, if you say you are increasing by a step of 2, and one of your characters is Y, so if you give a shift, so you cross Z and then what? I wanted it to get back to A, so kind of a cyclic thing. So I wanted to know where the A starts from. A starts from, what is the ASCII code of A? I stored that at S, right? And then given so I read the string, every character of the string one by one is L. Then I calculated the ASCII value of L, and then find out the difference from the start of A. So what character it is, added the step, and then give the percentage of 26, so that if it goes beyond Z, it comes back to from this side, and then added with S. S is a starting value, starting ASCII value of S. So it ensures me that if you it will be an alphabetical character itself. So it will be a cyclic thing, like, so characters will be changed, and if it goes beyond Z, it will come through A, B, C, D, etc. That's it. And then I add it with convert it to the character, and then concatenate it to B.
Okay. Thank you very much.
So there were other people who wanted you to go slow. I guess they were looking for some explanations.
Which one?
I'm not sure which ones, because they were just saying in general that you should slow down a bit. That was perhaps because they were trying to follow every detail.
No, but I can tell you that most of the program. Right? I just wanted to tell you that most of the programs are there in my slides, and what I can do, I can share my slides.
Yeah, right. That would help.
Most of the programs are already written in the list in my slides. So once I share the slides, things will be clearer, and we can have a better discussion once you see the slides itself.
Yeah. Excuse me, sir.
Yeah.
Yeah, can you show us the code on the calculation of mode that you showed us?
Yeah, why not? Mode
Yeah.
calculation, yeah.
Yeah, so what I don't understand really, so in the X is a list.
Yeah.
And then you're making a set of it, and then you're again making it a list again.
Yeah, set is not a list. Set is not a list. You cannot do a set-like list-like operation with sets. So that is why I have to make it a list so that I can make list-like operations on that.
So basically, X and XD are the same, right? Here.
Sorry?
No.
No.
X
and yeah, the elements are the same, but now X is the set X, set of X. X is the sorry, I didn't miss. I missed your question. X is the original list.
It picks up the unique elements only. That's it. Set.
And the unique elements of X is set X. But set itself is not a list, so you cannot do the list operations on that. So I converted that to a list. So XD becomes a list which contains the distinct elements of X.
Okay. So and another question. So does count acts on XD? So if I do XD dot count,
I see. Look at this. I operated count on X.
Yeah, exactly.
So does it work on
XD? On XD.
No. So I collect the elements of XD, the distinct elements, will be taken one by one, and the count of those distinct elements on the original X is calculated.
Okay.
So if you treat it on XD, you would get one for every one of them.
You get one for everyone. Yeah.
No.
Oh, right. Okay.
That was the basic idea of changing into a set first time.
Right. Okay.
And I also point out that for V in XD, that step would have worked even for a set. What would not have worked is this zip that was being done afterwards.
No, and finally I did XD of IX. That doesn't work for set.
Yeah, that will not work for a set. And you cannot refer to individual elements.
Right.
So all those things, that is why he had to convert the set back to a list. To use the list-like operations. But the first time he converted it into a set, it automatically took all the unique elements only once. So it was something like 5, 13, 10.
Okay. So XD essentially is a subset of X.
Well, no, X was a list.
Of course, it's a subset, but the point is, those are the distinct elements.
No, I think the language should be precise here. X was not a set, right?
Yeah, so, X is not a set. Yeah,
X is not a set, right? So the repeating lists are gone in XD.
Yeah. X.
Okay. Yeah. Thank you.
So, yeah, right. I guess it's just a matter of getting the language right, because otherwise it sometimes gets confusing.
Yes. I understand.
Sir, hello.
Please carry on.
Yes, I have a question. Can you please revisit your slide on percentage operation? I mean, remainder.
The percentage operation. There was I made a slide. Of course, yeah. It's nothing. Just wanted to do a kind of visualization.
The percentage is just remainder. So what exactly?
Remainder. No, he's right that I made this one.
Yes,
I mean, if your number is X, if your divisor is X, you want to calculate the remainder, then what will happen? Something that goes beyond X will try to fold back from 0. That's it. That's what you wanted to show. So if something protruding out, that will be folded back here. And if it's something protruding out this way, that will be entered from this side.
Okay.
Okay, Kishore is trying to say something, but I'm not very sure whether I can understand what he is saying.
Is he Kishore? No. Actually, no. I am not talking anything. Actually, somebody is talking. I don't know. Somebody's mic is on. Microphone is on.
Of course, everybody's microphone is on right now, I guess.
No, not everybody. But some noise is coming from outside.
So if you're not addressing us, could you please keep your mic off? Yeah, I think everybody's mic is off now. So,
and if there is any question, please ask. Please don't hesitate to ask.
No, but we can also, of course, continue the discussion on our WhatsApp platform and up tomorrow also. Because once I share these slides, it may be easier to go through the slides
Yeah, but
once
if they
again
have
and then.
any, if they have any
Yeah,
pressing
of course.
questions, they can ask now.
Of course, of
Otherwise, we
course.
can call it a day.
And can you please explain once more that memory issue? I mean, storing issue of floating point numbers.
I didn't talk about this.
He didn't talk about. You didn't talk about this at all. Actually,
Right.
that's my fault. Actually, because okay, let me just point out that when you showed the number 0.1, 0.2, 0.3, what came on the screen was 0.3, a lot of zeros followed by a 4 and so on. And quite several people asked why. Why is 0.3 looking like that? Okay, the simple short answer to that is internally a computer always uses a finite number of bits to store numbers, right? You all know that. Computers store numbers in zeros and ones. So they first convert whatever number you're trying to write in binary, base 2 number system, and then stores it in using just zeros and ones. Now, just like 1/3, for example, can you write 1/3 in decimal? Say, if I want to
No,
write down
it
1/3 in decimal, can you write it down? You actually can't. What you
no.
can do is put a dot on top.
Yeah,
Right?
that's a way of expression.
That's a way of expressing the fact that there is a infinite repetition.
Infinite
Right?
repetition, right?
But
Yeah.
frankly, on a computer, you cannot put dots on top. Now, the point
No.
is just like 1/3 does not have a finite decimal representation. Things like 0.2, 0.3, they do not have finite binary representation. Okay. 0.25 has a finite binary representation. 0.5 has a finite binary representation. Half, 1/4, 1/8, all these and sums and thereof, they have finite binary representation. Numbers like 1/3 don't. So 1/3 actually is an infinite binary. So even 0.3, 0.3, which is finite in decimal, is actually not finite in binary. If you remember, you knew how to convert these, right?
I know. Yeah. So that's why while giving the result,
the point
it
is
is not.
because you are actually saving it in a finite number of bits, the number which ultimately gets saved cannot be 0.3. You get that?
Yes.
If that's actually true even for 0.1 and 0.2 as well, but for 0.1, the number is close enough to 0.1 so that when Python finally shows you the number, it sort of does a bit of pre-processing. So since the number which is actually stored is very close to 0.1, it shows 0.1. In 0.3 is never stored exactly as 0.3. And that is, by the way, nothing to do with Python. That's the way numbers are stored in computers. It's just that whenever other computer programs often, even in Python, if you were to use print, you will not see 0.3 followed by lots of zeros and 4. You just see 0.3. Because print sort of polishes that up a bit. What you are seeing here is that the interpreter is directly showing you the internal things which are stored in the variables. And what is really stored is that. And this is something which you need to be very aware of if you're doing numerical computations, especially many numerical computations, one after the other. Then these very small differences can add up to a substantial change. Which is why being aware of these issues is very, very important if you want to do proper numerical computation.
So, can we know what kind of error can occur?
Well, these are called round-off errors. What kind of error will depend exactly on what kind of steps you're actually carrying out. The basic rule is you should never try subtracting two very close numbers. That's always going to be a problem. And okay, Onawala, can I take over your presentation for a while?
Okay.
I just wanted to illustrate a very simple thing to people.
Okay. I stop presentation.
No, you don't have to stop presentation. I will just.
I'm already done. So.
Okay, I will just.
Never mind.
Let me see whether I can get my. Okay, can you see my idle now?
Yes.
Okay, okay, now let's just ask ourselves a very simple question. Let's say A equals 1.0. Okay. And Unamoda has already talked about the while loop, right?
Yes.
What I do is while A is not equal to 0, exclamation mark equal to just stands for not equal to. So we are going to run a loop as long as A is not equal to 0. Okay, let me just do one thing before that. I just want a counter to count how many times my loop is running. So I will just initialize a variable I to 0. Okay. And then I will say while A is not equal to 0 colon A equals A by 2. That means every time the loop runs, A becomes halved. Is that okay? I'm dividing A by 2 every time the loop runs.
Yes.
And just to keep track of how many times I run the loop, I add 1 to I every time the loop runs. So I started at 0. The first time the loop runs, it becomes 1, then it becomes 2, then it becomes 3, and so on. Okay. Now, I want a prediction from you. How many times do you think this loop will run? Remember, this loop runs as long as A is not equal to 0. A starts at 1. I kept on halving it. So you should run as long as A. So how many times?
I think it should go.
Yeah, so others can also weigh in, right? So what is the opinion? How many times should this loop run?
I think it should be infinity.
Okay. Theoretically, it should be infinity. Let's give it a try. That's right, because
it should not be infinity.
Yeah, the point is, of course, it's not an infinite loop. An
Because
infinite loop would have run for an infinite amount of time.
Lowest.
And let's see, it actually runs for 1075 times. Okay. Now, I want all of you to notice this and think about why this happened. But before you do that, let me just show you something strange. And again, this has nothing to do with Python, by the way. This is the way computers store numbers. So don't go back and think that this is what Python is doing. Okay. Every programming language would have done the same thing. It may not be as easy to code this in every programming language, but that's a different thing altogether. So I'm now starting with A equals 1 and B equals 1. Earlier I had just one number 1. Now I have two numbers A and B. And instead of checking whether A is 0, what I'm checking is I'm checking whether A plus B is not equal to B. Right?
Okay.
You should realize that this condition mathematically is exactly the same as A not equal to 0. Right? And I do exactly the same thing. I do A equal to A by 2. I keep on halving A and keep on adding 1 to I. Of course, there's one problem. I forgot to initialize I back to 0.
Yeah,
so
subtract. We have to subtract.
So 1075 is already the value starting from. Okay, then I should have remembered to subtract. But anyway, it doesn't matter. But we'll see how many more times it runs. So prediction, what should you think after I run this loop? What should the value of I be?
Theoretically, it will be like double or more, but it will come at 1075 only.
That means it will not run at all.
Yes. Sorry.
No. It's already 1075, right?
Yeah.
So if it comes at 1075 at the end of the loop, it means the loop did not run at all.
Yes.
Is that what you're predicting? That the loop will not run at all? Why not? Because the first time, remember, A is back to 1, B is back to 1. I'm halving A every time.
But we haven't set I as a starting point. I is not.
So I is 1075 to begin with, right? So that was my mistake, right? I should have put I back to 0. I forgot to do that. So whatever answer you will get will already have a 1075 added to it. But now, what do you think should the answer be? Should it be 2150?
It should be.
Well, let's check. And so this loop runs only 53 times. Now, this is something which actually is key to the way in which computers store numbers. Somebody already, I saw put out on the chat that this depends on the way minimum number is stored, etc. It's a bit more complicated than that. It's not just that. It depends exactly on the way IEEE 754, the standard way of storing numbers, which almost every computer in the universe uses nowadays. It depends on that. This is a fascinating topic, and those of you who want to study numerical computation should actually definitely try learning more about this. You can look it up on the net. There are plenty of resources. But my submission is that these two small pieces of code, both of which should have been infinite loops but run for a finite amount of time, and the second one runs a lot less than the first one. You should try to understand exactly why the numbers are coming the way they are. Why is it 1075 and 53? You should be able to figure out once you know the IEEE 754 format.
Will the second loop run for 53 times irrespective of whether the first loop ran or not?
Yeah, the first loop has nothing to do with it.
Okay.
The second loop, if you start with A equals 1, B equals 1, it will run exactly 53 times.
What if we change the value of B?
Yeah, it will change. Then 53 will change. But exactly how, you should be able to figure it out. This is a simple puzzle. It's a puzzle about the way, if you know binary numbers and if you know the way, okay, just knowing binary numbers won't work. You have to also know exactly how a binary number is stored in a computer. It's not done in a very straightforward, obvious way that you might think. Okay. For example, 0 point, you don't write a point. There's no way to write a point, right? So some things have to be done differently. You all remember that when you're storing numbers in a computer, all you have are zeros and ones, nothing else. So you can't write decimal points, you can't write negative signs.
So we can write powers of 10?
No. Or you could, but that would be stupid. You would write powers of 2.
Yeah, sorry, powers of 2.
But you can actually store powers of 10. You can store powers of 10 if you want to. But it would be rather difficult to work.
Okay.
Okay, the signed Mantissa exponent format in 32-bit. Yeah, that's exactly what it is, but not the necessarily 32-bit, could be 64-bit as well. But this is something which is which everybody who seriously wants to do numerical computing should look into, because what kind of errors you can get into in a computer. The trouble is, most people tend to think that computers always give you the right answer. They don't. It's important to know where they make a mistake.
I'm sorry to interrupt, but side Mantissa, I didn't understand side Mantissa exponent. What is that?
Oh.
I didn't understand.
Okay, the point is the way in which numbers are stored are actually, say, okay, the problem is we have only 10 minutes in this session. Maybe I will just take some time off another session to describe this in a bit bigger way.
Okay.
Because this will take time. It's not a very short thing.
Okay.
But anyway, you know what a Mantissa and an exponent is, right? In ordinary numbers, when you write 3.7 into 10 to the 6. 3.7 is your Mantissa, 6 is your exponent.
I don't think I'm familiar with this.
That's just name, right?
Okay. Yeah.
But you know how to write things in that format.
Yeah.
Right?
Yeah.
So you do the similar thing in binary, but with some special ways in which you can actually store numbers with less space.
Okay.
Some simple things are used.
Okay.
Okay, Shaumarita Datta had a question about Can you please explain the logic compiler uses for sort, making it so fast? It's not the firstly, it's not a compiler, it's an interpreter. There's a difference, but that's not the real point. The point is Python uses one of the fastest sorting algorithms known to humankind. TimSort is actually the fastest one. That is way more complicated than bubble sort, or is sort of a hybrid between bubble sort and merge sort. Okay. Yeah, I think we can have a mini. Abhijita is saying this. I think we can have a mini session on this on number representation, especially if people are interested in doing numerical computations later. Number representations would be nice. So I think I will take half an hour on that sometime.
Will you be explaining about TimSort or bubble sort more?
No, not really. Bubble sort, maybe. TimSort is way too complicated to explain in a over the net.
Okay.
And bubble sort, the point is bubbles. The one reason why computer engineers, people who study computer science, study sorting algorithms a lot is because of the fact that there are various ways of doing it, and you can actually illustrate very nicely why one is slower than the other, why one is faster than the other. Computer scientists spend a lot of time in dealing with things called complexity. How many times or how many steps a particular program takes. Okay. And you can have different algorithms for doing the same thing. But one may take a lot of steps, the other may take a small number of steps. For example, let me just give a very much simpler example. Suppose you want to raise, different algorithms have different complexities. So the point is sorting is one particular problem for which there are several algorithms which are both easy to understand or easy to calculate complexity of, and you can demonstrate that why one method is worse than the other or better than the other, and so on. So for computer scientists, sorting is a very important problem because it helps you to understand basic ideas of computer science, things like how complex an algorithm is, and so on.
Okay.
And
sir, can you please tell something more about time module?
Well, time module is simply a module which provides you the way with various functions which can help the computer read its internal time and present it in various ways.
Ananda, just a minute. Tomorrow, I think I have to talk about modules and packages, and I'll try to touch upon time module.
Okay, that's great. That's great. But Abhijita, I don't know about that. I think one thing that I'm not very sure whether that was in the list, but we might have missed, which is functions.
Yes. Tomorrow I'll talk about that.
Yeah, you will have to talk about writing your own functions.
Yeah, definitely, I'll do that. Tomorrow I'll talk about modules and packages and function, of course.
Okay.
We have only 5 minutes. If there is any question, please ask. But we have to.
If there is a question related to what was talked about today, that would be better.
Yes, of course. I think there is no other question. So thanks to the speaker for this wonderful session. And what we observed today is that we started with 170 participants out of 250, and end up with 130 at the end of the session. So that is we have to think about it. Why all the participants are not joining? So we request all the participants, all 250 participants, to join this session tomorrow and make a grand success. So thank you.
One problem would be lots of people
I think there are heterogeneous people. There are some people who are quite familiar with these initial things, so they have left. They will join in the later part of the workshop when we talk about more complicated things. Yes. I believe so.
Because the network is
about very rudimentary things.
We will show. Okay, so let's complete our today's session, and we will come back tomorrow once again. Thank you.
Thank you very much.
Thank you.
Thank you, everybody.